So thanks to Ruslan for setting the context, and we're now all aligned and have the right mindset and spirit to learn even more about NLP. So in the pre-learn sessions and in this morning's opening keynote, we heard about what natural language is, what it is not yet, and perhaps what it can never be. But the question might be on your mind, okay, I work for Refinitiv, so why should I care, right? If I'm a product manager, if I'm a technical analyst, or if I'm a business analyst, what does it actually mean for us, and how do we include NLP in production, in an actual offering? And this requires a couple of changes in your thinking to be successful. In the traditional world, things are binary. A piece of software, as you all know, either works fine or there's something wrong. You know, you'll have to call customer support or reboot your machine, etc. We all know that. But it's a pretty sort of works or doesn't work binary type of approach. In the new world of natural language processing, you need to get accustomed that things work to a certain degree, right? So for some cases, you get the right output. For others, you get the wrong output, but that does not mean the system is broken. So there is a technical distinction, a qualitative distinction between something being broken and something delivering merely the wrong result, which you may personally consider broken in some sense as well, but it's not the same thing. One case is a software fault, and the other one is a case of inaccuracy that is an intrinsic property of the method used, and methods get improved over the time. And you know, we are working on research here to do that, but it will never be perfect. And this lack of perfection is something that people really struggle with, because we just got used to software always returning the same result, haven't we? The second point, in the traditional world, there is one algorithm, let's say, to sort a list of things alphabetically, and you have one algorithm and it will always sort everything perfectly well. Now in the new world, suddenly there is a dependency on individual languages. Suddenly you may want to have to ask yourself, okay, how do I sort a list of words in Chinese? You will find out actually in Chinese it's not obvious to split the words from each other, because they may be connected with no intermittent white space. And in your own cultural background, if you're not actually Chinese native speaker, you may be quite accustomed to be able to break things into words because there's a little white space in between them. For Chinese, you actually need a complex algorithm which sometimes fails to break symbols into words that they belong to. So instead of one algorithm works for everything, we have different languages that may require entirely different approaches. So it's no longer possible to swap out one thing for another in a sort of, you know, hot plug type of way. Then in the traditional world, you may have teams with 10 software engineers, and to make sure they run in sync, you know, you throw in a project manager for good measure, and that's a sort of traditional teams. Perhaps you have, you know, front end and back end and user experience and so on. But that's not the point here. The point is that there's much more interdisciplinary expertise required in the new world of language processing, because not only may you have computational linguists, experimental psychologists, of course, we are very lucky to have already plenty of UX gurus in the team, but you may also need statisticians, machine learning specialists, and so on. And these are not only scarce resources, they're also expensive resources. And as you will see, you may hope to need them only for a short while, but that is actually an illusion. So a lot of people ask me, just tell me what's the best method. You know, you're the expert, you've read all these papers, just tell me the best one, and we'll just pick that, right? We'll buy the company or we'll implement the paper and we're done. Actually, the question about what is the best is kind of asking the wrong question, because it depends very much what your criteria are for best for what, best with respect to what dimension exactly. Let's take summarization. A summary is a shorter piece of text that contains the essential bits of a longer piece of text, perhaps you might say. But then, how readable is the summary? Is it easy to understand? We heard this morning about autism, so there are different user groups with very different personal requirements. Same is true in professional space. Not everybody is equally literate. not everybody's a native speaker of English. Is the summary coherent? Is there a logical flow underlining the produced summary, the produced shorter version of the longer document? Is the summary complete with respect to the main facts? Is it even possible for three humans to agree what are the three most essential facts of a document? These are questions that are very hard to answer, and you may be surprised about the outcome if you did an experiment in your own team about, typical tasks that you have and measuring how many people agree on stuff, actually, when this is formally accounted for. So the overlap with handcrafted reference summaries by information professionals, that is a very difficult question, and we'll get back to that. And then the speed of the summary generation. Is that important? Do you care at all? Some things are very speed conscious or speed sensitive. They require near real-time processing or even real-time processing, whereas others, it's fine to run stuff overnight. So the question of efficiency. And then, because we're dealing with human language, the ability of an algorithm to work for multiple language. And there's a difference here between being language agnostic, which means one algorithm works for any language because it does not exploit the language intrinsic ability, versus an algorithm that supports, let's say, 5 languages, but if you need a 6th or 7th language, you need to add resources, lexicons, rules, train models, etc. Take some non-trivial action to support additional so-called lingware, linguistic resources. So the gist of this slide is actually not that there are many dimensions to summarization specifically. I really wanted to use summarization here just as an example for what is your problem that you're dealing with in the use cases today, or in fact your problem when you go back to your unit where you come from, and you hopefully take some of these lessons on board from today. There is no way around understanding the domain and understanding the technology. So at Refinitiv, we have a lot of domain expertise, and that's fantastic. What we still have to crack in a better way, I believe, is to bring the knowledge to the people who are already domain expert about how the technology works, and to the technologists to get a better understanding of how the domain is structured. Only then can we exploit the domain expertise and bring it together with the technology to make our customers happy. So, and then I'm really big on evaluation. Well, you might say, he's a scientist, that's what he does, right? But why do I have to care about that? Can't they do that for us? I believe that the first statement is very true. What you don't measure, you can't improve. Because you may make a change, you may think you're improving something, but unless you've been able to quantify that somehow, it may actually be an illusion. Your change may have improved one little example that you tried, but it may have worsened the performance on 17 other things that you didn't try. So unless you have a systematically constructed data set that you keep running where you measure the average behavior, which is after all what matters, you're basically flying blind. That's the metaphor I like to use from airline traffic. And then if you don't know how well your current human process works, you won't be able to judge whether an automation process was successful. So no point having a massive content transformation initiative, for example, if you don't actually know where you are right now, because you will receive some kind of accuracy scores, but you will not know, okay, is it 10% better or is it perhaps 4% worse than before? It's cheaper, but do I have to sacrifice quality? Perhaps not. So take multiple measurements and repeat your measurements on the way, and hopefully you'll see a gradual improvement over time. And then the third one is something that people that have worked with me know already, and those of you who haven't yet, I want to drive this point home in particular. So a lot of people think, okay, NLP has some error rate, right? So X% of examples it gets wrong. I can accept that. But then maybe it's 95% correct, and then the last 5%, maybe in 5 years, it's going to be 100%. No, it won't ever be 100%. And the reason is we as humans, we cannot agree 100% either. And the degree to which human subjects agree on what is actually the right output, that the machine should have produced is actually the upper bound of what the machine will ever possibly achieve. So if humans only agree 70% of the time, then the best the machine can do is reach that 70%. So that 70% is the machine's 100%, not the real 100%. And that really needs to inform the conversation when people discuss about what is possible from a technological point of view and what isn't possible, not because the technology is immature, but because it never will reach that state. Because as long as we as humans who actually define what is the truth to the machine, especially when we use machine learning, but also if we evaluate rule-based systems, that's really the glass ceiling that we just can't break through. So not 100%, please remember that one, very important. Finally, let's assume you take some NLP component, whether you're helping people with disabilities or you're helping financial traders generate more profit. It doesn't really matter, but people like to think of that as a project. You meet, you launch an initiative that has a limited time span, and at the end of it, the hope is you have a software component that automates a process that was perhaps previously accomplished by human analysts. So it's going to be automatic, it's going to be cheap, it's going to be fast, it's going to be repeatable, all the typical advantages for which we love the machine. But here's the bad news, it's not a project, it's a process, which means it actually doesn't ever end. And this will scare the accountants, because the accountants will want to have an end in sight where the payments stop. So part of this workshop's mission is also to inform everybody, I'm sorry, the payments won't stop, because machine learning is not a project that terminates on Tuesday the 2nd, 2021. You actually need to eventually refresh and refresh again, retrain again all these models to keep them fresh. Model maintenance is not something that traditional software engineers are very aware of, because if software works, let's say a sorting algorithm, as I mentioned earlier, it will work forever. There's not going to be a change to the way you sort unless you introduce new characters to an alphabet. But with machine learning, the data changes. For example, new companies are formed. They will be given new names. So new words appear in use. So the probabilities and frequencies of words like company names, they change. New nouns are coined, Brexit, for example, DDoS, acronyms, even new verbs. I Googled it last night, people say nowadays. This verb didn't exist in the English lexicon. Because language changes and because the world changes and we talk about the world, the probabilities change, and that means the statistical distributions need to be reassessed. Models need to be refreshed. If you don't do that, if you don't budget for it, your models will face decay. And the notion of decay is something we typically only associate with biological bodies, after they pass away, and not with computer software, which seems so sort of abstract and sterile, but because machine learning is inferred, induced, estimated from real-life data, it reflects real-life properties, and that includes word frequencies, transition probabilities, how likely is the word Brexit to follow the word hard, for example. This was not a probability that was non-zero in 2012, because actually, the word wasn't even coined. So, therefore, plan your ongoing resources after deploying the NLP components. Regular model refresh requires new annotated data, and it requires, even more expensive than what I've been saying so far, so brace yourself, expertise in the support team. Because to retrain a model, you need to understand how that works. So solution improvement, those of you who have been watching my deep dive presentation yesterday, they have already seen this particular slide. Solution improvements are often not linear. So it's not like this, you start at some accuracy number and you gently develop it further and the system gets better and better. If you zoom in these lines, this part may look a little bit like this linear function. it climbs a little bit, but it stays mostly flat. But what is really happening is there are these points of step change where you can achieve massive progress, but in order to do that, you need to throw everything you've already done out of the window and adopt a new paradigm. In this morning's opening keynote, we heard how that happened in machine translation. There were statistical machine translation systems that kicked out all the rule-based systems that have been invested massively since the Cold War times, because machine translation has had strategic importance, as we heard. And all of the statistical systems were recently thrown out and replaced by neural systems. And no doubt there will be another push, we just don't know what kind of push in the near future. And again, people have to replace the knowledge, replace the systems, and have another step change. But what is problematic from a psychological point of view, having worked in this field in sort of industry for over 11 years, is when you can no longer create these small improvements and you kind of hit that brick wall, people have a reluctance to let it all go and to trust a new unproven technique that requires you to learn new mathematics, that require you to integrate new libraries from a more practical point of view. All of that creates a bit of resistance from any organization, and I would encourage you to be agents of change to help the company overcome this resistance so that we can benefit from these step changes and be up there and not stay down here. So finally, errors compound. Very small two-word sentence, dramatic implications. Imagine there is a system shown here with 3 components, C1, C2, and C3. And let's say they are linguistic components, so they have an accuracy rate, or you might say error rate. If the accuracy is 90%, the error rate is 10%, 100 minus x. So 90%, 85%, and 60%. What is the overall accuracy of the system? These numbers sound all sort of reasonable. The last one is perhaps a little lower, but 90%, yeah, that's close to perception. And we just heard humans are not even, 100% anyhow. But often the component errors actually compound. So if we multiply all these numbers, we actually obtain there's a dot too many, 46%, just under 46% in fact. So less than half correctness, despite the components individually doing quite all right. And this is sometimes something that shocks people when we work together on things and people see all these numbers with 80s and 90s, and then the overall thing is measured and oops, it's not that great. Question?
Can you give a concrete example for this?
Yes. So let's say you want to summarize a document. Yeah? You may all have tried out the summarization system in Microsoft Word. I think they took it out of the most recent version, but the desktop version at least had it. Internally, it assigns the word class so that it can tell whether walk was used as a verb or as a noun. I went for a walk. I like to walk, different syntax. This is one component that is a sort of upstream component. And after that, many other steps may have taken. Now, if this so-called part of speech tagging has a 90% error rate and the subsequent summarization process 60%, and in between you take, let's say, something that extracts noun phrases, has 85%, then the overall accuracy is less than half. And that's shocking. You will basically consider that rubbish, to use the English word. And what I want you to understand is to diagnose these things. It's no longer about, to the developers among you, simple assertions that are Boolean and either fire to alert you to a problem or they accept that everything is correct, or test cases, but instead you need to basically introduce quantitative testing in between these components where the blue errors are. Otherwise you will not detect that there's a problem. And even harder still is to actually assess what kind of error rate is actually tolerable for human end users. And this is where our friends from user experience come in, because I think it is very important going forward that before we invest massively in technology, we actually conduct human studies that try to assess what error rate is still acceptable. so that we can find out whether something is actually worth building given our knowledge of the current state of the art. So to wrap up, I know you want coffee, and there's one talk in between me and the coffee. That's Laura's presentation. To wrap up, the following ingredients for success in NLP have been given, and some of them have been almost forgotten, I would argue. Algorithms, machine learning models that are based on these algorithms, features that basically are human-defined signals where we exploit our own domain expertise to guide the machine, to tell it what is worth extracting from the raw data so that it can make the right decision. The data, which we learned is just the beginning, and I hope this workshop will get us beyond the beginning to do some non-trivial processing of that data. And then the annotations where we as humans enrich the data so that the machine can then learn from these annotations what we expect it to output. But then there's the final point, and that often doesn't get emphasized as much as I would like to see it emphasized, and that's the methodology part. It's much neglected. The annotation of the data, the evaluation of systems in a proper way, following a strict experimental protocol, is actually key to succeeding in deploying successful NLP systems, and is not talked about a lot in, perhaps even in academia, when a lot of the conversation is about the maths of the machine learning models, or companies that care about, okay, how does the API look like? Can I buy this off the shelf? Do we have to build or buy? We're going to talk about this more as part of this workshop. But I just want to create some attention on your side, some awareness that the partitioning of the data, the annotation, guideline, authoring, the tools that support the annotation process, the so-called inter-annotator agreement. In other words, how often do humans agree on the right answer or not? And the choice of the best evaluation metric among the several hundred metrics out there for various tasks with particular pros and cons, and understanding when to pick what metric and how to assess whether a metric is giving you a good result or an okay result or a great result, and where the state of the art is. All this methodology is not mentioned a lot, and I want you to focus on that, or be aware that there's a lot of time investment required in getting that right. Without that last part, you, in my experience, will not likely be successful to develop and deploy your product that contains hopefully some amazing NLP, such as the use cases developed at this workshop.